So today we're doing the notes from chapter 13. Remember, tomorrow, since you weren't here, we were discussing tomorrow we have the quiz on chapter 12, and then the test is on Thursday.
Yes. Okay.
All right, so this is moving from just random things to probability. Some of this will be things you've already done before. So a random phenomena is a situation in which we know what outcomes can possibly occur, but we don't know what particular outcome will happen. Okay? There are lots of those that happen all the time, every day. Each occasion upon which we observe a random phenomena is called a trial. I think it's unfortunate that they use trial in more than one context. At each trial, we note the value of the random phenomena and call that the trial's outcome. The collection of all possible outcomes is called the sample space. So if you're rolling a standard number cube, i.e. a six-sided die, there are 6 things that can happen. You could get a 1, a 2, a 3, a 4, a 5, or a 6. Just a quick for your information, did you know that on a standard number die that the opposite sides always add up to 7? 1 and 6 are on opposite sides, 2 and 5 are on opposite sides, and 3 and 4 are on opposite sides, which is frequently a way you can spot someone who is cheating at dice. They'll have weighted die so that it comes up a particular number more often, and a lot of times with those, they forget to put the opposites adding up to 7, and you can be like, these are not standard die. Anyway, so the law of large numbers. We have actually talked about this, but have never said what this is called. States that under the correct conditions, that if we repeat a random process over and over and over again, the proportion of times that an event occurs settles down to a particular number called the probability of the event. The conditions that must be fulfilled are, first, the outcomes must have the same probability for each trial. So like flipping a coin. Every time you flip a coin, you have the same probability of getting a heads or a tail. And the events must be independent.
Is this your favorite unit?
I don't know, why?
I don't know, you just seem very, independent. You know? No? Just me?
Yeah, I'm faking my enthusiasm.
Oh.
I find that once you can do that, life is a lot easier.
No. That's real.
Yeah.
So funny, Brody.
So, meaning that the outcome of one trial does not affect the outcome of the next trial. So, if you're picking cards out of a deck of cards, that means that you have to replace them between trials, otherwise the events are dependent on one another.
Oh, yeah.
Independent and dependent events is actually something I teach my 7th grade pre-algebra kids.
That's why.
You learned this in my 7th grade class a long time ago.
Independent, dependent?
Yep. So, the probability that A occurs if you take enough trials will be the number of times A occurs divided by the total number of trials. This is why when we were looking at if you flip a coin 10 times and it turned up to be heads 7 times out of 10, you probably wouldn't think much of it. If you flipped it 10 million times and 7 million times it came out to be heads, you would be like, you're cheating, right? In the long run, the law of large numbers states that if you do this enough times, you should settle down to the correct probability, that it should be 50%. So, of particular interest to us, oh, and I didn't read this part, as the total number of trials increases without bound. In other words, as the total number of trials heads towards infinity. You got to do a lot of trials. With flipping coins, it's not as many. If it was something where it's a little, it's a close thing, you're going to need to do more trials.
Is there like a cutoff of like? Oh,
No.
now we know we're good.
No. It should, if you do enough, what is enough?
Showing a pattern.
Yeah, it should start settling down to whatever the actual probability is. So one of the big things you need to know is that the rule of large numbers says nothing about short-run behavior. The so-called law of averages is a myth.
What law of
Yeah,
averages?
what does that mean?
So, any baseball fans? All right. So let's say that your favorite player has a 357 batting average, which is pretty good, and has not hit safely in his last 8 appearances at the plate. Almost inevitably, you can count on some announcer to say he's due for a hit.
Because his average is
Because of
what?
his average.
Because of his average. That's a short run thing.
So
They're- Yeah, they're like on average, he should be, he's due. He should be getting a hit this time. I'm like, no, those are independent events. Pardon?
I don't get it.
Okay, let's say that I was flipping a coin. Forget the baseball. I'm flipping a coin. I have flipped 5 heads in a row. If you're like, you're due to flip a tails, you're wrong.
Oh yeah.
Because they are independent events.
Oh, I see. It's
Now-
okay. I understand.
What
It's
now?
like, actually, I don't know if this is. It's like saying, like each time you're starting over. So like you.
Correct.
It's not like, oh, you need to draw tails now or flip tails now. You
Right.
still have 50% chance heads, 50% tails. Okay.
Yes.
trials independent of each
Yeah.
other.
Okay.
Right. Since the trials are independent of one another, then what you have done previously doesn't matter. Okay, so anytime someone talks about the law of averages,
You're
just
lying.
snort derisively. I mean, the coin doesn't know what it's flipped the last ever times. Now, you can make a case for saying, back to the sports example, that they're not truly independent of one another. Because the player, isn't exactly the same person that he was last time he was at the plate. This is the philosophical idea of you can't step into the same stream twice.
Because the water.
Once you have stepped into that stream, you have altered the stream. It's no longer the same stream. Which then goes to one of my favorite ideas of what movie that you have seen would you like to see again for the very first time?
Oh, that's a great.
I think it's a really good question. I have a short list of ones. Scott Pilgrim versus the World is one that I would like to see again for the very first time.
Brody, we talked about this all last year in physics, and you nerded out over your love for, not PETA, what's the good one that you love in Hunger Games? The one that dies. Yes, you, okay.
We never heard about that.
Yep, okay. I was gonna say Hunger Games. Have you seen that movie? Or
I
that
have.
series?
I saw the first one. I think I may have seen the second one, and I was like, yeah, okay, whatever.
You don't want
Oh,
to see it. Finnick dies.
Finnick, that's his name. Yeah, maybe if I could see the whole series again for the first time. Or Extraction.
She
That
loves
is
that
such
movie.
a good movie.
She loves that
love
movie.
that movie. Have you seen that movie?
I can't remember if I have or not. If I did, it was eminently forgettable.
It's got
You
Chris
need to
Hemsworth.
watch it.
It's got Chris Hemsworth in it,
so
yeah.
good.
He's like an extractor.
Or what's the one?
He pulls
Bonnie and
teeth?
Clyde?
No, man, he
No, I know.
Wait, I actually not seen that.
Yeah, maybe
Highwaymen?
it's
Have you seen that
I think
movie?
it's hired. to
Which
go
one?
in and, like,
Highwaymen?
extract people from like if they've been
It's the
taken
Bonnie and Clyde
captive.
movie.
He's hired to go in and take them back to.
I'm trying. I think
It's so good.
I may have.
Or Deepwater Horizon. Have you seen that movie?
No.
The bar movie.
I'm gonna make a list of movies that you need to watch this weekend. Deepwater Horizon, Extraction, and Highwaymen
He's gonna
are
watch
like
none of them.
top 3. They're so good.
Okay.
That's a no.
You don't believe me. And they're most of them.
They're loosely based on a historical event.
Well, yeah. Deepwater Horizon is.
Is that the oil rig one?
Yes.
That's
Yeah.
what we need to watch.
Highwaymen is Bonnie and Clyde. We'll watch it on Wednesday. No, we gotta study
No,
this
we
out
can
on
do it.
Wednesday.
All right. So moving on. The theoretical probability of a particular event selected from a group of equally likely outcomes is the number of outcomes in the event divided.
Bye.
Yeah, that sentence doesn't make a lot of sense. At the very least needs by. So it's the number of outcomes, and I'm going to add into that desired outcomes divided by the total number of possible outcomes. So the probability of A is the number of outcomes that give you A, the desired outcome, divided by the possible outcomes.
Wait, isn't it the same thing with the other one?
No. The other one we're doing an experiment. The number of times A occurs divided by the total number of trials.
Oh.
So for flipping a coin, I want to flip heads. Well, there's only one heads, and there are only 2 possibilities. That's why it's 1/2. Whereas this, I flipped this 4 bazillion times, and hopefully it's getting really close to 50%.
Yeah.
So your book mentions this, I don't know why, but subjective or personal probability. We won't study this. It's the idea that it's based on your own uncertainty. This is a little bit like when I said, okay, if I flip the coin 100 times, at what point do you know, how many heads do I have to flip before you go, there's something wrong with that coin?
8.
80
Oh wait, out of how many? I'm sorry.
out of 100.
Out of 100?
90 out of 100? It would take a lot less than that for me.
70, 80.
80.
I'd probably say, for me, it would be more like 70.
Really?
Yeah.
Yeah, 80.
That's starting to get into the territory of the law of large numbers.
I just feel like 70. I feel like that could happen.
Yeah, I know.
Like 20 times. I could flip head 20 times if I really tried.
If you really worked at it.
Really worked at it.
All right. So, rules of formal probability. All of these are in the 7th grade math book here at Northland Christian.
Oh gosh. Yep. We might fail this one.
So rule number 1, the probability is a number between 1 and 0. So 0 is less than or equal to the probability that A occurs, which is less than or equal to 1. It is inclusive of those. If the probability is 0, the event never happens. If the probability is 1, the event always happens. Okay, that's a basic idea. I think all of you understand that one already. The probability assignment rule says that the set of all possible outcomes of a trial must have probabilities that sum to 1. And I think that's a pretty easy idea as well. The complement rule. I don't think we called it the complement rule in 7th grade. But here's the idea. The probability of an event occurring is 1 minus the probability that the event doesn't occur. This is a really helpful idea. So let's say that you're rolling 2 6-sided die and you want the probability that you don't get a 2. Well, there's lots and lots of combinations that aren't 2. If you were formally going to do that, you would have to find the probability that you got 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. You would have to find all those probabilities. Or you could just find what's the probability that you get a 2 and subtract that from 1. The probability you get a 2 is 1 out of, how many are there? It's 6 by 6, 1 out of 36. So the probability you don't get a 2 is 5 out of 36.
Why'd you get 36? We have 2 dice.
6 sides each. So there's 6 possibilities. So there's 36 total different things that you could do. 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and... So there's 36 different possibilities. Only one of those comes up to be 2. Just 1 and 1. So there's 1 out of 36 that does come up to be 2. So there are 35 that don't. It's like unbirthdays from Alice in Wonderland. Anyone? Anyone? No? Where they wish people a very merry unbirthday?
That movie scares me.
I know.
Oh, not the Johnny Depp version. Go back and watch the original Disney animated.
Oh, okay.
It's much less creepy.
Oh.
Still don't like it.
I've never watched
Yeah.
I just never understood it. Like, why is it so?
It's weird to start with, and then Tim Burton did it, and that made it even
That made it
weirder.
So
Yeah.
weird.
You like just like the Charlie and the Chocolate Factory with Johnny Depp. Like that one's creepy, but the original's not.
Which one? I'm sorry.
The Charlie and the Chocolate Factory.
Oh,
Remember, you know the original one.
oh, the original one is yeah,
But the one with Johnny Depp is creepy.
yeah, because it's Tim
Forgot about
Burton.
Johnny Depp.
Pardon?
Forgot about that guy, Johnny Depp.
He's had some great movies, but he's had some.
He's
weird movies.
he's a very talented actor.
What's a good movie he's in?
You know, like the Scissorhands movie.
Edward
That's-
Scissorhands.
That's disgusting.
What
to
is
watch.
that? He's like some horror movie?
No, kind of, but it's just creepy. It's more like.
It's a love story.
No, it is not.
It
It
is.
kind of is, but it's just more disturbing than like
What
scary.
is it? About?
He has scissors for hands, but he.
And he goes around living
he-
his life?
Yes.
Why would you?
Oh no, he's in hiding for the most part. But a girl finds him, and they fall in love. And
Oh.
He's got scars all over his face. It's just like
'Cause-
he's anti-so. It's weird.
yeah.
Um.
Anyway, so disjoint or mutually exclusive events have no outcomes in common. And I'm going to write a comment on that. Disjoint is not independent. Students always want to make those the same thing. That's not the same thing at all.
Wait, students want to make disjoint and...
Disjoint and independent mean the same thing. They don't mean the same thing.
Oh.
So the addition rule says that for two disjoint events, we'll call them A and B. The probability that one or the other occurs is the sum of the probabilities of the two events. So let's say that somehow or another you could figure out the probability that you got an A on tomorrow's quiz, and you could figure out the probability that you got a B on tomorrow's quiz. The probability you got an A or a B, those are disjoint events, they can't both happen, would be the sum of those two probabilities.
Can we find the probabilities?
But this.
I'm not sure my calculator has that many decimal places.
Whoa, Mr. Davis. Oh.
Good one.
This quiz tomorrow is independent of our last quizzes.
And the test is
In
really
theory, at
hard.
least.
So it doesn't matter what we made on the last one. We can still get an A on this one.
That's true.
I got
All right.
Oh, you got an A on last
The
one.
last rule is the multiplication rule,
so good. We should just play kids together next time.
That was disgusting. High five.
I know.
That was-
which says that for two independent events, A and B, the probability that both A and B occur is the probabilities of the two events, is the product of the probabilities of the two events. So the probability that A and B happen is the probability of A times the probability of B. So for example, if I roll a dice and I flip a coin, the probability that I get a 3 and a heads is 1/6 times 1/2. Right? So notice independent events aren't disjoint. Okay? So again, don't conflate those two.
Wait, could you explain the rule like before again? You add the sums of A and B and then what happens?
Oh, so So the probability that in that same one that I rolled a 3 or I flipped a heads would be 1/3 plus 1/2.
Okay.
Oh, except, sorry, those aren't disjoint events because they both can happen.
A
Um,
disjoint event would be the test one, the quiz.
Pardon?
Making an A on the quiz or making a B on the quiz.
That would be disjoint.
Right, because they have no outcomes in common. All right. That is it